Meteorology and Climatology. Climatology, an Outline. Objectives. Climatology is the scientific study of climate, climatic variations, climatic extremes, their influences on a variety of Earth's processes. It is one of the major branches of Earth and atmospheric sciences. This lesson is oriented to give an outline on the subject climatology. After attending this lesson, the user would be able to understand the basic concepts of climatology and its contents. Topics in climatology are focused to understand the global atmospheric conditions that are controlling the climate and weather, their distribution, and their impacts. It is also aimed at learning the general climatological processes, modifications made by human beings, types of weather and weather cycles. The interplay between the atmosphere and other spheres of the Earth in influencing the global climate are very essential aspects to be studied in Earth and atmospheric sciences. Introduction. Under the umbrella of Earth and atmospheric sciences, the global climatic processes and their impacts are studied in the subjects like meteorology and climatology. The word climate is derived from the Greek word klimat, denoting inclination or latitude. It originally stood for a simple band of latitude on Earth. When the scientists began to ponder around the possibility of climate change, their thoughts naturally turned towards the sun, its radiation, and the role of Earth's atmosphere, hydrosphere, and biosphere in terms of climate and weather with reference to latitudes. The birth of the subject started from these issues. It was stated very clearly by the philosophers that the changing sun is changing the climate. It holds good while studying climatology and meteorology, the twin subjects of Earth and atmospheric sciences. In this lesson, an outline of the subject of climatology is presented. Climatology, an interdisciplinary science. Climatology is the science of studying the average atmospheric conditions of a region on long-term perspective. It includes a systematic study of the atmospheric conditions pertaining to both weather and climate. Climatology also aims to study the nature, causes, and interpretations of its spatial variation and its association with the other spheres. It is closely related to both meteorology and geography. All the global atmospheric processes are spatially distributed and are varying with reference to time. It deals with all climatic components that are responsible in controlling these processes. Climatic components. The term climate can be defined as the average weather conditions for a particular location and for a specific period of time. The average weather conditions are reflected in the form of climatologically parameters or variables. The very essential climatic parameters are temperature, precipitation, atmospheric pressure, humidity, and velocity and direction of winds. The elements of weather are recorded and analyzed by the scientists called climatologists. This is one of the oldest sciences of nature, and it is an ancient science too. The ancient science. These ancient literatures contain enormous information about the processes of cloud formation, occurrence of rain, and the seasonal cycles that are caused by the movement of Earth around the sun. Initially, the subject of meteorology was given much importance by the ancient Indians. This has happened as early as 3000 BC. There is a chronology behind the growth of climatological studies in the world. The chronology. If we look back to the ancient observations, we may be able to find the core concepts and thoughts of this subject. It was around 600 BC, Thales described the water cycle. He was the first Greek meteorologist to work on this line. In 400 BC, Democritus predicted the changes in the weather with proper evidences. The first written records about the atmosphere were given by Hippocrates in the year 400 BC. Aristotle writes about meteorology in the year 350 BC. Aristotle was the first to bring out the first ever compendium of meteorology as a weather science. It was mainly based on the works of the Greeks. The world was divided into three temperate zones. The tropical zone, temperate zone, and the frigid zone are the basic divisions of the globe. Indian scholars and philosophers contributed significantly to this subject. The work of Indians. In India, the reference to meteorological aspects can be traced from the works of the Upanishads. The ancient people were the first to record the climatic observations in the form of charts, maps, drawings, rock paintings, and canvas paintings. In the year 500 AD, Varahamihira's classical work, called as Brihat Samhita, provided a clear evidence that a deep knowledge of atmospheric processes existed in India even in those times. During the 7th century, Kalidasa, in his epic Meghaduta, mentions about the date of onset of monsoon over central India and traces the path of monsoon clouds. These paved the way for all modern works in climatology. The modern works. The oldest known Irish diary, containing the weather data, was of the year 1682-83. The Middle Ages, from 7th century to 17th century, have shown a lot of outstanding analysis about global weather and climate. The first classification of clouds was done as early as 1803. The oldest preserved diary of meteorological observations was found in an observatory's archives belonging to the period between 1826 to 1828. The newspaper Inland published the weather information regularly every year since 1839. Over a period of time, the twin subjects climatology and meteorology have grown as very important scientific disciplines. Climatology and meteorology. The root for climatology lies in the subject of meteorology. It was the Greeks who tried to understand the atmosphere and its influence on life. The 20th century has witnessed a lot of achievements in the development of tools and techniques in order to obtain the regular and accurate data of weather and climate. Technological advancements have helped to operationalize many of the applications. Satellite-based, real-time, and continuous monitoring of all the segments of the whole globe helps to understand the trends of weather and climate well in advance. Aim of studying climatology. The primary goal of climatology is to study the unique characteristics of atmosphere, its structure and composition in controlling the global climate, origin and types of climates, causes and processes influencing the climatic variations, elements of weather, and the impact of climate on human and other life. Agricultural climate, aviation climate, bioclimate, medical climate, macroclimate, microclimate, mesoclimate, paleoclimate, and Arctic climate are some areas of special studies coming under the broad science of climatology. An interdisciplinary science. Climatology is an interdisciplinary subject. It involves the basic principles and application areas of physics, chemistry, geology, mathematics, electronics, botany, zoology, and environmental science. It has direct links with the subjects like oceanography, forestry, hydrology, glaciology, agriculture, animal husbandry, fisheries, horticulture, floriculture, marine biology, microbiology. Today, climatology is a well-grown field of science. It has several major and minor branches. Major and minor branches. The major branches are historical climatology, physical and dynamic climatology, regional climatology, satellite climatology, tropical climatology, paleoclimatology, and applied climatology. Diversified fields. Historical climatology deals with the study of historical changes in climate and their effect on human history and development. The physical climatology is mainly concerned with the various atmospheric phenomena and their resultant climates. Regional climatology deals with the regional variations of climatic conditions, which include microclimate, local climate, mesoclimate, and macroclimate. Paleoclimatology is yet another branch which encompasses the effects of climatic change over the entire history of the Earth. Applied climatology deals with climatic controls of human activities and the application of climatic knowledge in solving unique problems faced by human population. In this respect, climatology is fully related to ecology. Climatology and Ecology. Ecology is the study of the mutual relationship between organisms and their environment. The study of Earth's ecosystems involves both biotic and abiotic components. The environment of living organisms is directly affected by weather and climate, including those changes in climate that are gradually being made by human beings. Climatology has a direct bearing on ecology, ecosystems, and the well-being of all life. They are all based on the global climate and cyclical processes. Global climate and cyclical processes. The global climate and many cyclical processes on the Earth are all controlled by the atmosphere and its processes. These processes have both direct and indirect influence on several impacts on the world. Among those, the weather and climate are the two distinctive features that are having very direct influence on the whole globe and the life. The science of climatology draws full attention due to these impacts on the Earth and life. The four dimensions of the subject are structure and dynamics of the atmosphere, sun's radiation, global cyclic processes, and their impacts on all segments of the Earth. The first one is related to the atmosphere. Climatology and Atmosphere. Atmosphere is an important segment of the globe containing air, water vapor, and particulate matter. Atmosphere is an envelope that is attached with the globe due to the gravitational pull of the Earth. The life on the Earth exists because of the presence of atmosphere. It protects all life by blocking out some of the harmful radiation coming from the sun. Atmosphere is fully interlinked with all other spheres like hydrosphere, lithosphere, and biosphere. The weather and climate are a part of the atmospheric effects which control the life and life support systems. The primary aspect in the subject of climatology is in analyzing the atmospheric variables and data acquisition. In order to do that, it is necessary to understand the atmosphere, atmospheric chemistry, the gas laws, the vertical structure of the Earth's atmosphere. Importance of atmosphere. Atmosphere is the multi-layered gaseous envelope attached to the planet Earth. It is a unique sphere of air, gases, and water vapor. The height of this huge mass is estimated to range from 16,000 to 29,000 kilometers from the sea level. This is an essential environmental segment for the life support systems of biosphere and hydrosphere. The vertical variation in temperature and concentration of gases have a significant impact on global scales. The layer concerning with weather and climate is troposphere. Atmosphere is composed of three major constituents as gases, water vapor, and aerosols. Some are permanent or constant gases, and some are variable gases. They obey Boyle's gas law, Lusac's law, Charles' law, and combined gas law. The study of atmosphere. Under the umbrella of climatology, the structure and composition of the atmosphere are studied first. An understanding of the thickness and disposition of different layers like troposphere, stratosphere, and mesosphere are needed. Under the conditions of the atmosphere, the following aspects are to be understood: elements of weather and climate, structure and composition of the atmosphere, insolation and energy balance, atmospheric temperature, atmospheric pressure and motion. Climatology and global energy. Solar energy and gravitational energy are the fundamental sources of energy for the Earth's climate system. The sun is the source of the energy that causes the motion of the atmosphere and thereby controls weather and climate. Any change in the energy from the sun received at the Earth's surface will therefore affect climate. During stable conditions, there has to be a balance between the energy received from the sun and the energy that the Earth radiates back into space. This energy is mainly radiated in the form of long wave radiation corresponding to the mean temperature of the Earth. Climatology involves a study of insolation, flow of energy, absorption of radiation, emission of radiation, distribution of radiation, heat budget or energy balance, human influence on radiation balance. Solar radiation. The sun is the ultimate source of energy on Earth. Radiant energy is the energy propagated in the form of electromagnetic waves. The proportion of solar radiation falling on a non-luminous body, which the latter reflects, is known as albedo. It is the reflective quality of the surface. Albedo of Earth is 0.3. About 30% of the solar radiation is reflected back into the space. These waves do not need molecules to propagate them, and in a vacuum they travel at nearly 3 lakh kilometers per second. Insolation is maximum at tropics and decreases towards poles, 75% at equator, 50% along Arctic, Antarctic circles, and 40% at poles. The factors influencing insolation are the angle of incidence, the length of the day, the transparency of the atmosphere, heating and cooling of the atmosphere. The nature of radiation. Climatology analyzes the nature of sun's radiation, the solar source, the details about photosphere, chromospheres, and sunspots are studied in detail. The Earth's surface and solar energy are in continuous contacts as a never-ending cycle. The atmosphere and solar radiation, in terms of reflection, scattering, and transmission, are the basic elements of study in climatology. The energy balance. The energy system of the Earth involves solar radiation, gravity, and geothermal sources. The solar energy plays a very significant role in heating the Earth's surface and the atmosphere. Because of these, it is responsible for the movement of air and oceanic currents. The radiant energy is the driving force for the global water cycle, rock, and the biogeochemical cycles. Without sunlight, there is no photosynthesis in plants, and there may not be any food for the other life. Study of weather and climate. The term weather refers to the sum total of short-term variations in atmospheric conditions in terms of temperature, pressure, wind, water vapor, clouds, precipitation, and visibility. The term climate refers to the long-term aggregate of weather conditions of a region or the globe in terms of several atmospheric parameters. Elements of weather and climate. The following are the elements of weather and climate: temperature, air pressure, wind, humidity, precipitation, cloudiness. These elements are controlled by various factors like latitude, altitudes, unequal distribution of land and water, air-sea interface, ocean-water circulation, and geomorphological conditions. Temperature is the first element. Atmospheric temperatures, seasons, daily temperature changes, daytime heating, nighttime cooling, daily temperature range, seasonal lag, and extreme temperatures, factors influencing the vertical distribution of temperature, factors influencing the horizontal distribution of temperature, the global heat budget, impact of latitude, surface properties of the Earth, slope and topography, the dynamic factors of climate, and monitoring of temperature over the Earth's surface are the very essential parts of study in climatology. Atmospheric temperature. Climatology involves the study of transfer of heat energy, heating and cooling of the atmosphere, mean temperatures, distribution of temperature, inversion of temperature, role of temperature in other environmental segments like hydrosphere and biosphere. Uneven distribution of temperature. The distribution of temperature varies horizontally and vertically. The uneven distribution of temperature comes due to latitude, distribution of land and sea, relief and altitude, ocean currents, planetary winds, vegetal cover, nature of the soil, slope and aspect. The three processes. Sun is the major source of temperature in the atmosphere and also in the oceans. Heating and cooling of the atmosphere is controlled by direct sunlight. There is also a transfer of energy from the Earth through convection, conduction, and re-radiation. The processes of heating of the atmosphere are: convection is the upward movement of air. Conduction is from high temperature zone to low temperature zones. Radiation is radiant energy emitted by a body in the form of heat. Re-radiation also heats the air. Climatology and global pressure. Climatology studies the pressure gradient, pressure types, variations in atmospheric pressure, horizontal distribution of air pressure, pressure belts and shifting of pressure belts, atmospheric motion and air circulation, geostrophic wind and gradient wind, wind direction and speed and classification of wind. Distribution of air pressure. The horizontal distribution of air pressure depends on air temperature, Earth's rotation, and zones of low or high pressure. Climatology and atmospheric circulation. The large-scale structure of the atmospheric circulation varies from year to year, but the basic climatological structure remains fairly constant. The movement of air in the atmosphere is known as atmosphere circulation. Atmospheric circulation denotes the motion of air due to pressure gradient from local to global scales. It has spatial and temporal patterns of circulation components. It involves primary circulation or long-term circulation, secondary circulation, seasonal circulation, and diurnal circulation. Types of circulation. There are 4 types of air circulation in the atmosphere as primary, secondary, seasonal, and diurnal. The primary circulation of air is related to the trade winds, westerly winds, and polar winds. The secondary circulation is related to cyclones and anticyclones. The seasonal circulation is related to monsoons and air masses. The diurnal circulation is related to land, sea breezes, mountain or valley breezes. Forces controlling circulation. Atmospheric circulation, speed and direction of winds are controlled by gravitational force, pressure gravitational force, Coriolis force, friction force. Atmospheric pressure and motion. Air is a mixture of gases and hence has its own weight. Air exerts pressure. Atmospheric pressure is maximum at sea level. It decreases with increasing altitudes. Air pressure varies vertically and horizontally. The distribution of atmospheric pressure is controlled by altitude, temperature, air circulation, Earth's rotation, water vapor, and other factors. Dynamics of the atmosphere. Under the concept of dynamics of the atmosphere, the following aspects are to be understood: the atmospheric circulation, the local and seasonal winds, atmospheric humidity and condensation, fogs, their origin and types, clouds, their origin and types, precipitation and its distribution. Local and seasonal winds. Wind is the circulation of air relative to the surface of the earth. Climatology analyzes the local and seasonal winds in detail. The periodic local winds include the breezes between land and sea and the breezes from mountains and valleys. The non-periodic local winds include the hot local winds and cold local winds. There are some more types of local winds as beneficial local winds and non-beneficial local winds. Climatology involves the evaluation of zonal circulation of atmosphere as global wind belts, tropical circulation, doldrums, westerlies, and trade winds, mid-latitude circulation, polar circulation, meridional circulation, jet streams, El Nina and La Nina. Circulation features. Earth's rotation causes many circulation features. The resulting Coriolis effect causes the meridional flow to be disrupted as winds are deflected to the right of their course in the northern hemisphere and to the left of their course in the southern hemisphere. Atmospheric circulation can be divided into 3 convection cells in each hemisphere. From equator to the poles, these cells are the Hadley cell, Ferrel cell, and polar cell. These are latitudinal circulation features. The longitudinal circulation features include Walker circulation and El Nino southern oscillation circulation. All are studied in climatology. Moisture in the atmosphere. Atmosphere contains water vapor as moisture in air. The changes of state of matter in the hydrologic cycle, relative humidity, evaporation and transpiration, condensation near the ground, distribution of dew, mist and fog, foggy places, condensation above the surface, origin of clouds, their vertical motion in the atmosphere, adiabatic heating and cooling, lapse rates, the regional variation in precipitation, the variation in precipitation through time, and climatic water balance are the very essential aspects involved in climatology. Atmospheric humidity and condensation. The term humidity refers to the amount of water vapor present in a parcel of air having a unit volume and temperature. Water vapor is released during the process of evaporation from water bodies of land and oceans. Since water vapor is a very important constituent of the atmosphere, it plays a significant role in controlling the climate. It is present up to a height of 5 kilometers from the Earth's surface. Condensation is the process of converting water vapor into liquid and solid forms. Atmospheric water undergoes phase changes through the exchange or transfer of heat energy. The energy in the form of heat required to carry out all these conversions is called as the latent heat. Climatology analyzes humidity. Climatology deals with the elements of the hydrologic cycle, including humidity capacity of air, types of humidity and their measurement, evaporation and its rate, evapotranspiration, condensation and forms of condensation, cooling of air and adiabatic change of temperature, stability and instability of the atmosphere. Fogs, their origin and types. Fogs are special types of clouds consisting minute water droplets existing in suspension in the air near the ground surface. Fogs generally reduce the horizontal visibility. Fog is formed when the moist air becomes saturated and reaches its dew point. Further cooling of this mass makes the water vapor to condense around the dust particles and creates the dense, smoky fog. There are a dozen bases of classification available in climatology to study the types of fogs. Types of fogs. The major types of fog studied are radiation fog, fog produced over land when radiational cooling reduces the air temperature to or below its dew point. It is also known as ground fog and valley fog. Steam fog, evaporation, mixing fog. Upslope fog, fog formed as moist, stable air flows upward over a topographic barrier. Tropical air mass fog. Frontal fogs. Fogs are distributed in different parts of the world. Climatology also analyzes the effects of fogs and the natural or man-induced dispersal of fogs. Clouds, their origin and types. Clouds are the aggregates of innumerable tiny water droplets in the atmosphere above the ground surface. Clouds are formed due to condensation of water vapor. Global patterns of precipitation depend on the clouds. Clouds play a significant role in controlling the heat budget of the Earth's surface. The study of clouds involved the classification of clouds and the characteristic features of clouds. The structure, altitude, occurrence and appearance of the following types of clouds are studied in climatology. Monsoons and climatology. Climatology involves the study of monsoons, their origin, types and distribution. Monsoon is a complex phenomena of the atmosphere. The origin of monsoons is based on thermal concept and dynamic concept. Monsoon refers to the annual cycle of dryness and wetness with seasonally shifting winds produced by changing atmosphere pressure systems. The study of seasonal winds provides detailed large-scale information on monsoons. Monsoon has a flow pattern of general atmospheric circulation over a wide geographical area. Monsoons have a clear and dominant wind in one direction during one season and in reverse direction during the other season. Seasons. The seasons are the result of the tilt of the Earth's axis. The Earth's axis is tilted from perpendicular to the plane of the elliptic globe by 23.45 degrees. This tilting is what gives us the 4 seasons of the year: spring, summer, autumn or fall, and winter. Since the axis is tilted, different parts of the globe are oriented towards the sun at different times of the year. Summer is warmer than winter in each hemisphere because the sun's rays hit the earth at a more direct angle during summer than during winter. It also reflects it in the duration of the days that are much longer than the nights during the summer. During the winter, the sun's rays hit on the earth at an extreme angle, and due to which the days are very short. These effects are due to the tilt of the earth's axis. Seasons are very essential aspects in this subject. These provide us the rainfall, snowfall, and other forms of precipitation. Precipitation and distribution. The term precipitation refers to the fall of atmospheric moisture either in the form of liquids or solids. Climatology includes the study of precipitation, its measurement over space and time. The forms of precipitation includes rain, drizzle, snow, ice pellets, hail, and sleet. Among these, rain is the most widespread form of precipitation. Climatology analyzes the types of precipitation, controls of precipitation, and various rainfall regimes. The rainfall regimes studied are equatorial rainfall regime, tropical rainfall regime, monsoonal rainfall regime, continental rainfall regime, Mediterranean rainfall regime, maritime rainfall regime. These are considered as contributions of the atmosphere. In addition to these, there are a lot of disturbances happening on the Earth due to global atmospheric processes. Atmospheric disturbances. Atmospheric disturbances include the basic understanding of air masses and extreme events in the atmosphere. The term air mass is used to denote a large body of air whose dominant physical properties are more or less uniform horizontally and vertically for hundreds of kilometers. Temperature and moisture are the two major properties. Air mass controls the weather conditions of an area. It plays a major role in the transfer of energy in the atmosphere through its movement. Air masses are subjected to thermodynamic and mechanical modification. Due to these, air masses are divided into cold air and warm air masses. Climatology attempts to classify the air masses based on thermodynamic and geographical factors. An air front is defined as the transition zone between two air masses of different density. Hence, climatology deals with the distribution of air fronts. Air is a poor conductor. One of the important properties of air is that it is a poor conductor of energy. This means that when two different bodies of air come together, they do not readily mix each other. Rather, each body of air will retain its individual properties and a boundary forms between them. When two large air masses meet, the boundary that separates them is called as an air front. Fronts represent fairly abrupt transitions between two large air masses. Air fronts. The term air front is used to denote the sloping boundary between two opposing air masses having contrasting physical properties. These properties are temperature, humidity, pressure, and wind direction. Air fronts differ from each other in terms of their location and spread. Air fronts are classified based on their characteristics as warm front, cold front, occluded front, and stationary front. Earth's surface has three major frontal zones as polar frontal zone, Arctic frontal zone, and intertropical frontal zone. The weather associated with warm and cold fronts are also studied in climatology. Air fronts extend not only in the horizontal direction but in the vertical as well. Air fronts appear and disappear in the atmosphere. The processes of formation of new fronts and decaying of old fronts is known as Frontogenesis. It is an important aspect in climatology. Frontgenesis. Frontogenesis is the generation or intensification of a front. It occurs when warm air converges onto colder air and the horizontal temperature gradient amplifies by at least an order of magnitude. The conditions responsible for frontogenesis are temperature difference and opposite directions of air masses. Extreme events in atmosphere. Extreme events are those which are originated by natural or human factors causing severe impact on the environment like a hazard. These events exceed the tolerable magnitude in the atmosphere causing irreparable loss to life and properties. Atmospheric extreme events include severe storms, lightning, hailstorm, and thunderstorms. Cyclones are also very dangerous natural hazards generated by the atmosphere. Cyclones. Climatology includes the study of cyclones. Cyclones are the centers of low atmospheric pressure in which air blows inwards in anti-clockwise direction in the northern hemisphere and clockwise direction in the southern hemisphere. Cyclones are considered to be the major atmospheric disturbances. They are classified into extratropical cyclones, temperate, and tropical cyclones. One of the most powerful and destructive types of cyclonic storms is the tropical cyclone. It is also known as hurricane or typhoon. Anticyclones are opposite in character to those of cyclones. It shows divergent air circulation in all directions from a high pressure center. The other issues are the occurrence of hurricanes. Hurricanes. Tropical cyclones are low pressure systems having a diameter of 650 kilometers, moving with an energy equivalent to 10,000 atomic bombs. They are called as hurricanes in the North Atlantic Ocean and as typhoons in the North Pacific Ocean. The wind speed may be as high as 180 to 400 kilometers per hour, giving a rainfall of 2,000 millimeters per day as seen in Philippines. The other extreme event is the thunderstorm. Thunderstorms. A thunderstorm is a form of turbulent weather. It is also known as an electrical storm, a lightning storm, thunder shower, or simply a storm. A thunderstorm develops in three stages as cumulus stage, mature stage, and dissipating stage. Stronger thunderstorm cells are capable of producing tornadoes and waterspouts. Tornadoes. Tornadoes are funnel-shaped, violent, dark storms where in the upper portion is like an umbrella and the lower portion is like a pipe touching the ground surface. It is a small, intense cyclone in which the air is spiraling at tremendous velocity. It appears as a dark funnel cloud. Climatology also includes the impacts of hazards and their side effects like floods. World climatic types. Climatic parameters have a profound influence on vegetation, soil, and fauna of different regions of the world. World climates depend on the nature of parameters like temperature and precipitation and their influence over fauna and flora of ecosystems. Under the concept of world climatic types, the distribution of climatic types and biomes and classification of climatic types are studied in detail. The world is rich in holding many endless variety of climatic type. The factors that produce the climate in any given place are called as climatic controls. Classification of climates. The classification of climatic types are studied in detail. The aspects considered in this are intensity of sunshine and its variation with latitude, distribution of land and water, ocean currents, prevailing winds, positions of high and low pressure areas, mountain barriers, and altitude. Notable climatic classifications. Climatic classification of regions are very essential for several human activities. Climatic variations are seen with reference to latitudes and altitudes. Both vertical and horizontal variation of climate are analyzed in climatology. Several climatic zones have been identified so far. World climatic zones are classified based on empirical, numerical, and genetic approaches. The important classification schemes studied are Köppen's multi-tiered classification system, Thornthwaite's classification, genetic classification, and composite classification. Climatic types and biomes. Climatology helps in classifying the global biomes. A biome is a large, natural, identical ecosystem having unique assemblage of plant and animal communities, having a definite distributional pattern in terms of climatic and soil conditions. The word biomes are also classified into three major groups as tropical biomes, rainforest, monsoon forest, savanna, Sahara. Temperate biomes, forests, grassland, Mediterranean, humid, steppe, boreal. Tundra biomes, Arctic, alpine, and these include more number of suborders. Regional climatology. Climatology attempts to evaluate the regional climatic conditions. The types of climates at regional level are microclimate, mesoclimate, macroclimate, and global climate. Microclimate is related to the climatic conditions of a small climatic region. Mesoclimate is related to the climate of a small area of the Earth's surface, an acre to several square kilometers. Macroclimate is related to the climate of a much larger area, state, or country. Global climate refers to the climate related to the entire globe. Climatic change. The global climate is always changing. Evidence shows that climate has changed in the past, and there are also evidences that show that it will change in future too. Variation in Earth's climatic conditions are seen in both space and time. The reason behind this variation is the dynamic nature of atmosphere. Global climate may change due to natural causes and man-made activities. The change may occur drastically or gradually. The notable modifications may come in moisture, cloudiness, precipitation, and in the heat balance of the Earth atmosphere system. The changes may be cyclic and rhythmic. Climate change can adversely affect the lives of millions. Due to these, climatology analyzes the causes and effects of climatic change and find remedial measures. The indicators of climatic change. There are several theories and causes of climatic changes. In climatology, all of them are studied to understand the past and predict the future. There are several kinds of indicators reflecting the climatic changes. The notable ones are biological indicators. Floral, faunal remain in fossils. Geological indicators. Sedimentary deposits. Cryogenic indicators. Ice ages, glaciers, ice sheets. Tectonic indicators. Sea floor spreading and sea level changes. Geomorphological indicators. Historical records of droughts and floods and migration of man and animals. Dendrochronology is one aspect coming under these analyses. The global warming refers to increase in global surface and atmospheric temperature, affecting the global radiation balance. It needs a sound weather forecast methodology. Weather forecasting is a part of climatic studies. Weather forecast. Weather forecasting is a major field of predicting the weather conditions comprising the temperature of atmospheric air, movement of wind, humidity, sunshine hours, cloudiness, precipitation, and atmospheric disturbances over a place or region well in advance. Different sources of weather and climatological data are collected on daily, weekly, monthly, and annual basis from global network of observatories and used to forecast. Methods in weather forecast. The weather forecasting methods include synoptic forecasting methods, statistical forecasting method, and numerical forecasting method. Weather forecasts are of various types as short-range weather forecasts up to 48 hours, medium-range weather forecasts 3 days to 2 weeks, long-range weather forecasts 2 weeks to seasons. Weather warning is a quick forecast indicating that hazardous weather is either imminent or actually occurring within the specified forecast area. Weather watch is a forecast indicating the instant atmospheric conditions and to tell whether it is favorable or hazardous. Satellite climatology. Remote sensing refers to the acquisition of information about a target or phenomenon from a distance. The climate is reflected in the form of low-frequency signal of weather that involves interactions among Earth's environmental systems. Both remote sensing and climate are related to radiation transfer through Earth's atmosphere. Combining these two disciplines forms satellite climatology. It emphasizes understanding the different techniques used to determine, from spaceborne platforms, the atmospheric, oceanic, and land surface conditions important to climate and its variations, and the interpretation of these remotely sensed data in the context of climate dynamics and synoptic climatology. Satellite climatology applications. The most common type of satellite climatology is a cloud composite, which is a measure of the frequency and persistence of clouds over a particular region. Cloud composites can be derived from geostationary or polar orbiting satellites. The primary focus is on the use of satellite imageries. Because of the great spatial coverage, diurnal composites of imagery over monthly, seasonal, and annual timescales can reveal the amplitude of diurnal cloudiness in relation to geographic features such as land and water boundaries and changes in their elevation. It is a very interesting study in climatology. Tropical climatology. This subject, tropical climatology, is of great relevance to the tropics as climate in many ways controls the lives and economic activities of the approximately 2,400 million people living in tropical regions. The tropical climates have profound effects that reach far beyond the limits of the regions where they actually prevail. The global general circulation is largely driven by the export of considerable amounts of heat energy from tropical to extratropical latitudes. A large part of all atmospheric water content originates from the tropics, and intermittent tropical phenomena like El Nino Southern Oscillation ENSO or ENSO. These not only influence the climates over extensive tropical areas, but many parts of the extratropics. The subject of tropical climatology is an important aspect in the subject of climatology. Paleoclimatology. Paleoclimatology refers to the study of changes in climate that has taken place on a large scale in the entire history of the Earth. It uses a variety of indirect methods from the earth and life sciences to obtain data previously preserved within the rocks, sediments, ice sheets, tree rings, corals, shells, and microfossils. Paleoclimatologists use these records to determine the past states of the Earth's various climate regions. Studies of the past changes in the environment and biodiversity can reflect on the current situation and the impact of climate on mass extinctions and biotic recovery. Leading role of climatologists. Climatologists all over the world play a very significant role in studying the atmospheric phenomena by using meteorological data. The meteorological data are gathered by surface observation stations, air stations, using sensors in satellites, and also by using radar. Climatologists interpret the meteorological data and prepare the daily, weekly, monthly, and annual weather reports. Forecasting the climatic changes for the knowledge of the public and their attention is a regular work of the climatologists. Climatic maps and charts. Weather and climatic maps and charts are prepared by the climatologists for routine use. In addition, climatologists conduct numerical simulations to understand and predict the global, regional, and local weather patterns. They apply the basic principles of meteorology to solve practical problems in the field of agriculture, pollution control, and water management. Problem-solving professionals. Climatologists are problem-solving professionals, tackling the issues like global warming, climate change, ozone depletion, desertification, cyclones, hurricanes, and other natural hazards are part of their professional work. Climatologists evaluate the long-term and short-term weather conditions. Conclusion. There is a saying that climate is what you expect, weather is what you get. Climatology is the scientific study of climate, climatic variations, climatic extremes, their influences on a variety of Earth's processes, their influence on the Earth's crust, oceans, and other water masses, climatic effects on human life and activities, effects of climate on the survival of vegetation and all animal life. In this lesson, a broad spectrum of areas that are studied in the subject of climatology are highlighted.